Today, we're diving deep into AWS VPC, Virtual Private Cloud, a core service that every cloud architect and developer needs to master. We'll be covering what a VPC is, its key components, security features, best practices, and a hands-on lab on AWS console. Let's jump right in. So, let's start with the basics. What exactly is an AWS VPC? According to AWS, a VPC is a virtual network dedicated to your AWS account, isolated from other virtual networks in the AWS cloud. This means you can define your IP address range, create subnets, and configure route tables and gateways, all within a secure, isolated environment. AWS VPC allows you to launch AWS resources in this logically isolated network. It gives you full control over your networking environment, including the ability to select your IP address range, create subnets, and configure route tables and network gateways. In essence, a VPC is your private section of the AWS cloud, where you can design and deploy your cloud infrastructure just as you would in a traditional on-premises network. The flexibility and control you get with VPCs make them the backbone of any robust AWS cloud architecture. Now that we've covered what a VPC is, let's delve into its key components. Each of these components plays a critical role in building and managing your network infrastructure. 1. Subnets. A subnet is a range of IP addresses within your VPC. You can divide your VPC into multiple subnets, each residing in a different availability zone, AZ. AWS recommends using subnets to group resources by common functionality or security requirements. For example, you might have public subnets for web servers and private subnets for databases. 2. Route tables. Route tables are essential for directing network traffic within your VPC. Each subnet in your VPC must be associated with a route table, which determines the next hop for each packet based on its destination IP address. The default route table provided by AWS routes traffic within your VPC, but you can add custom routes to direct traffic outside your VPC. 3. Internet Gateway, IGW. An Internet Gateway is a VPC component that allows communication between instances in your VPC and the Internet. It scales horizontally and is highly available, enabling instances in public subnets to connect to the Internet. 4. NAT Gateway, a network address translation. NAT Gateway allows instances in a private subnet to connect to the Internet or other AWS services, while preventing the Internet from initiating a connection with those instances. AWS recommends using NAT gateways over NAT instances due to their managed, scalable nature. 5. Security groups. Security groups act as stateful firewalls at the instance level. According to AWS documentation, they control inbound and outbound traffic based on rules you define. A key feature of security groups is that they allow you to permit or deny traffic to your instances, and the rules are automatically applied to any new instances that you associate with the group. 6. Network ACLs, access control lists. Network ACLs are an optional layer of security that acts as a stateless firewall at the subnet level. Unlike security groups, which are stateful, network ACLs apply rules to all inbound and outbound traffic at the subnet level, making them an additional layer of security within your VPC. Now, let's explore how you can connect your VPC to other VPCs or networks. AWS offers several options here, with VPC peering and transit gateway being the most prominent. 1. VPC peering. VPC peering allows you to connect two VPCs privately using AWS's global infrastructure, enabling them to communicate as if they were in the same network. Importantly, VPC peering is not transitive, meaning if VPC A is peered with VPC B and VPC B is peered with VPC C, VPC-A cannot communicate with VPC-C through VPC-B. 2. Transit gateway. A transit gateway simplifies network architecture by acting as a central hub that connects multiple VPCs and on-premises networks. Unlike VPC peering, Transit Gateway supports transitive routing, allowing you to easily manage large-scale network topologies. AWS recommends using Transit Gateway for complex environments where multiple VPCs and networks need to interconnect efficiently. Security is a critical aspect of any VPC setup. AWS VPC offers several layers of security to protect your cloud infrastructure. 1. Security groups. As we mentioned earlier, security groups are stateful firewalls that control inbound and outbound traffic to your instances. AWS recommends using them as your first line of defense, allowing you to define granular access control for each instance in your VPC. 2. Network ACLs. Network ACLs offer an additional layer of security at the subnet level. Since they are stateless, you need to define both inbound and outbound rules for any traffic to flow. AWS suggests using network ACLs for fine-grained control over the traffic entering and leaving your subnets. 3. VPC flow logs. VPC flow logs are an essential tool for monitoring and auditing network traffic within your VPC. They capture detailed information about the IP traffic going to and from network interfaces, which is invaluable for troubleshooting and security analysis. AWS provides detailed guidelines on configuring VPC flow logs to meet your monitoring and compliance needs. To get the most out of your AWS VPC, it's crucial to follow best practices that ensure security, scalability, and efficiency. Based on AWS recommendations, here are some key tips. 1. Plan your IP addressing. Choose your IP address range carefully to avoid overlap, especially if you plan on connecting multiple VPCs or extending your network with on-premises environments. AWS suggests using a large enough CADR block to accommodate future growth while avoiding common IP address ranges that might conflict with other networks. 2. Segment your network. Using subnets. AWS advises using subnets to isolate different tiers of your application, such as front-end, back-end, and database layers. This not only improves security, but also enhances the manageability and scalability of your architecture. 3. Implement security in layers. Combining security groups, network ACLs, and flow logs ensures a robust security posture. AWS emphasizes the importance of implementing defense in depth, where multiple security controls are layered to protect your resources from different types of threats. 4. Use multi-AZ deployments. Distribute your resources across multiple availability zones, AZs, for high availability and fault tolerance. AWS strongly recommends multi-AZ deployments for critical applications to ensure continuity in case of an AZ failure. 5. Regularly review and optimize. AWS documentation highlights the importance of regularly reviewing and optimizing your VPC configuration. This includes checking for unused resources, optimizing routing and security rules, and staying up to date with the latest AWS features and best practices. Now, let's dive into a hands-on lab using the AWS console.